Thank you so much, and it's a real privilege to be speaking to you today. Unfortunately, due to the sort of travel situation we're in, I can't be with you in person. I'm actually based in New Zealand, so I'm a fair bit away from where you are now. But luckily, this is a lovely part of the world to be stuck in. But we're looking forward to starting to be able to travel shortly and to be able to see you again in person. Now, I know we were having a few audio problems. I just wanted to make sure that you could hear my audio okay.
Yes, we can hear very clearly.
Well, that's great. So thank you again. So my role, I have a number of roles actually. So my role is to be the field Chief Technology Officer for Asia Pacific and Japan. So I've got a team of 20 field Chief Technology Officers around the region. And we help our customers who are dealing with the most challenging environments in all manner of kind of industries. Outside of my role at Dell Technologies, I'm also an angel investor and a mentor for startups. I'm also on the investment committee of a venture capital fund, and really helping to develop some of those new and emerging technologies that are going to make a big difference to the future that you're all going to be participating in. I must say it's probably been nearly 30 years since I was at university, so it's been quite a while now. But I'm really looking forward to having your input into some of the challenges that we're seeing today. As Dr. Oman mentioned earlier, data is really the core of business and society as we're moving forward. So we're seeing an explosion in the amount of data that we're collecting and the types of data that we're collecting. And we're seeing this change in the methods by which we maintain and collect the data to really moving away from this concept of managing data in silos or pools into this concept of dealing with data pipelines. And that's actually changing the whole way we think about computing and the whole way that we look to solve problems in industry and society. And the work that you'll be doing once you leave university and start working, in our businesses and society will be really focused around how to take the best advantage of that. Because we're kind of at a point in time now where many of these emerging technologies have become powerful enough to make a difference in this space. So whereas technologies like artificial intelligence back in the 70s were quite well known, some of the algorithms that we could use, they weren't really very effective because we didn't have enough computing power to be able to make the algorithms work in any useful kind of time period. And we didn't have the amount of data that we needed to really make those algorithms work effectively to demonstrate what we believed the potential of those were. Well, both of those things have now changed. We've moved from using commoditized processes to using purpose-built special co-processors and accelerators that allow us to be able to take those algorithms and to run them very quickly in multiple silicon. We've seen the emergence of GPUs and DPUs that are designed for being able to build machine learning algorithms based on leveraging large pools of data. We're moving towards neuromorphic processor architectures, which allow us to be able to drive some of those insights in real time. So we're starting to see the architectures coming through that will allow us to take advantage of of the data that we are collecting. On the data side of things, traditionally we've used sort of relational structured data repositories to be able to collect the information that we need. That is changing quite quickly as we're finding that much of the information that we're collecting and storing is of an unstructured type. So we're seeing streaming data coming from sensors like cameras and other types of sensors that we're building into the environment. We're seeing that being pulled into types of data that we're collecting through our experiences with the devices that we're using, with smartwatches and the phones that we're carrying, which are starting to collect biometric data, which is being tagged and aligned to our kind of efforts. And we're starting to build those sensors into the world around us. So all of these different types of data are making the whole concept of data management much more complex and difficult. The tools and technologies that we use and the the methodologies that we use are quite different. That's the first topic that we're going to talk about today, that's going to have the most impact on your journey as you move into society. So we've always had this concept around collecting and managing data, right from when we started sort of using some of these traditional data architectures back in the 60s and 70s to collect the data that we were using throughout our business environment. That's evolved quite quickly as we've started to share data more across our partners and across the landscape, to having standards around data governance and integration so that we can start to collect and integrate that data through from different sources. That's meant that we've had to really build a sense of how we manage data and how we connect that between these different types of repositories to allow that to be inferred intelligence and insight from that data. So the concept of data management really is broadened across all of these kind of landscapes. So it's not confined to one of these areas. It really encompasses a large swathe of the types of technologies that we're using. So the reason that this is becoming more and more important is that organizations are moving towards a data-driven form of making decisions and interacting with their consumers. But traditional management techniques were based around human interaction and inference and research and insight based on experience and knowledge. That knowledge is now no longer relevant to the way that business is changing so quickly as we move forward. So we're now starting to see as digital technology is entering our competitive environment and it's taking some of those changes, we need to be able to react in real time or even predict what the future is going to look like to be able to make good decisions based on that information. So organizations are starting to realize that they need to be able to retain as much of that information as possible, to be able to build systems that allow them to create competitive advantage that can drive insight from that. And we're starting to see a shift towards real-time data. So whereas we've had good methodologies around storing, maintaining, and creating insight from structured and large data pools, being data warehouses and data lakes, we're now starting to see that real-time streaming data is actually what creates the most value in an environment. So we're seeing this concept of changing data value over time, where being able to collect and act upon that information right at the very point that it's generated can have enormous value into our interactions and the way the decisions that we're kind of making. That value drops off quite quickly until after a few minutes, it's no longer relevant to the decisions that we're making right now. But very quickly, that data then builds in value again as we can start to correlate the data between different sources to be able to predict trends and inferences of models over time. So we're starting to see these different sort of technology landscapes building to allow us to look after streaming data that's coming in from those devices. We're using pipelines to be able to take information from cameras and real-time data sensors, apply machine learning models that we've built upon the data that we've stored, what's called big data, where we've looked at trends and change over time. And the algorithms that we build out of those systems, we can then move those to the edge of the network where we're interpreting the data as it's generated in real time in that streaming kind of sense. So whereas that big data is creating those trends and helping us build those models, the streaming data is where we're creating that real-time insight and value. And the architectures, the data management architectures that we're building have to be able to accommodate both ends of that spectrum. And the technologies and methodologies that we're using are very different. And there are a number of challenges here. So firstly, on the data side of things, the data itself is becoming much, much larger and far more complex. So there's, I think there's some instances of we're actually analyzing less than 0.5% of the data that we're generating in the environment. And that data is being generated in many, many more places. So whereas traditionally we would have a centralized architecture to be able to generate and collect, manage, maintain, and provide inference from that data, that's now spread across many aspects of our business architectures, right out to the very edge where we're collecting the data and then bringing that right through the core. We've also got some real challenges around how this information is being used. You will have heard of bias being a challenge. Bias has always been a problem in terms of the decision making that we run in these environments, and the artificial intelligence algorithms that we're training from our experience that we've used also instantiate some of that bias. So that bias is now being driven in real time and being driven by these algorithms. So we're starting to move from this sort of black box type architecture to a glass box architecture where we can see the algorithms and understand the inferences that they're making to comply with some of the regulatory functions that we have around the world and to be able to demonstrate trust in our customers' eyes as we're moving that. Now, the tools that we're using, I mentioned, are getting very different. There's a big trend towards open source architectures, simply because the technology is changing so quickly. So we have these open tools that are being built to drive analysis and storage of this information, to be able to extract meaning from that. And that has big changes on the infrastructure that we use. So whereas traditionally we would have used business analytics and business intelligence, data cubes and data warehouses that we would have been built inside of our own environment, now we're using cloud architectures, which allow us to grow and scale very quickly to accommodate the size of the data that we're inferring, and also allows us to be able to dip into pools of accelerated infrastructure to be able to drive insight and to be able to analyze that information in real time. Now, that infrastructure tends to be quite different depending on which part of the curve that we're operating in. As I mentioned earlier, GPUs and accelerators that are designed for being able to tune through lots of information very quickly are being used to build the models based on the data sets that we're accumulating over time. And then FPGAs and NPUs and neural processing architectures are being used to drive insight from those models at real time, not on the edge from a single point of data as we're collecting them. And so it's driving immense complexities across the architectures. The other challenge that we've got is that the expectations of business are changing quite dramatically. So many businesses, we believe, are not going to survive into the future if they don't evolve to leverage these data-centric architectures. So we're seeing many senior business leaders and teams really focusing their development efforts and putting a lot of investment into the way that they collect data, the way they share data, the way that they can use data up and down the value chains to be able to create real-time insight and dashboards of how their businesses are moving. We've seen a real change from kind of report-driven or historical sort of assessment of businesses and how they're performing to this real-time dashboard method of being able to see how those are operating and to be able to use that for decision-making in kind of real time. Now, the big challenge, which is what you're all kind of working towards, is that the skill sets and the types of roles that we need are very uncommon. It's very difficult to find the specific skills and capabilities that we need for these types of roles and these types of challenges that we're having in the marketplace. So your opportunity as you move into the marketplace is to be able to pick up these skills and capabilities and to be able to produce real value for organizations across the landscape. We're still building out some of the tool sets, and those will continue to change. So the ability to be able to learn these things quickly and to be able to apply them to the challenges that we're seeing is going to be absolutely key as we kind of move forward. So as I mentioned, for most organizations, this is really going to be a key focus for them in the next few years. So over 50% of data is going to be distributed amongst sort of on-premise, edge, and into our cloud architectures. So the skills and technology required to be able to find that data, understand the value that it's generating, be able to build metadata models, to be able to leverage the machine learning and artificial intelligence toolsets that we can wrap on top of it are going to be absolutely key. Most organizations expect that they're going to be analyzing and making insight and value from 100% of their data in real time over the next 5 to 10 years. That's going to require a dramatic change in the skills that they're using, the tools that they're using, and where they're implementing their architectures. we're seeing a real drive towards these edge devices where we're putting GPUs and accelerators and what would traditionally be in a data center server architectures right down onto the very edge of the network, building that into cameras, building it into manufacturing supply chains, building it into the world around us to be able to analyze that data and to be able to make insight from it. And as I mentioned earlier, 22% of teams think that they have got a real gap in their skills, and there's a change in where those skills need to be applied. So, traditionally teams would have spent half their time cleaning the data and getting it into a format by which it could be analyzed and used. We're now seeing tools coming through that can help to do some of that automatically. So teams are now being able to spend more of their time on innovation and driving new models and new capability, find new ways of visualizing that to be able to demonstrate that value to consumers and to the rest of the business. And we're seeing industries being able to pick this information up. So, most industries are moving towards a data-driven method of decision-making. That has been sort of quite a slow progression. Sort of traditional management techniques are built upon, as I mentioned earlier, experience and knowledge, and teaching those business leaders how to be able to use these dashboards to be able to make good decisions is taking a little while. So we're now seeing a little bit over half of organizations basing most of their decision making on data, and that will continue to build, we think, over the next kind of 5 to 10 years. And that's a key component of that is learning to trust the data. So oftentimes the data models and the machine learning and insights can throw up answers that look quite different to the answers that we would normally have seen when we were operating businesses. It can create new visibility to problems that we just didn't really understand. And as humans, we kind of can only analyze and synthesize so much data, whereas the machines that we're building can give us a much wider view of that. An interesting example of that, which ran a sporting event here in New Zealand called the America's Cup over the summer. And the America's Cup this year was built for the first time on these yachts which float above the water. They use, I don't know whether you might have seen them, but they use sails to be able to accelerate the boats and get them out of the water on these foils. And they actually spend the entire time around the racing track on these foil things. These are the first time that these types of boats have been used, and they were only had the ability to be able to build 2 of them, one for practice and then one for the eventual races that they kind of undertook. So one of the teams here, Team New Zealand, actually built a digital twin model based on the information that they were gleaning off the boat. They built sensors into the way the boat was moving through the water. And then they had a simulation that the sailors would use to sail the boat in the computer simulation around the course. And the computer would learn from the way that they sailed the boat what the outcomes they were looking for when they were trying to build this. Now, interestingly, very quickly, they started to notice as the computer was being trained that it started to drive the boat quite differently than the human sailors did. And the sailors have hundreds of years of experience between them at sailing these types of yachts. So they started to look at why the computer was starting to do things a bit differently. And it had actually been able to find faster and more efficient ways for the boat to be able to get around the course and to be able to take advantage of the wind shifts that had never occurred to the sailors. It just didn't make sense to them in their experience in the way that they were working on the water. So the computer became so good at this, they could use that to train the sailors themselves that were driving these boats on the water. And the data that they were creating and the digital twins that they simulated had an enormous impact on the way that they could manufacture the foils and the next generations of boats to be able to make sure they could take full advantage of the technology that was being available to them. So using that data-driven approach to insight and decision-making can be quite challenging, and we have to go through this pathway of teaching executives and teaching decision-makers about how to trust that data. The other side of that is actually on the consumer side. So as we're starting to share health-related information or information that's very personal to us, we need to be able to trust that organizations are maintaining that information and managing it in compliance with the privacy and governance elements that we expect them to, and that that data is being protected and ensured that it isn't leaking or being shared where it shouldn't be. So most organizations are going to build a large organization that sort of drives down this track. Sort of over 90% of them have it in their top 10 initiatives, and most of them are struggling to get the sorts of skills that you're building now to be able to help them to build those kind of capabilities. Now, one of these customers that we're working with is AeroFarms. So AeroFarms have actually taken the concept of a traditional farm, which is built in in a paddock or out in the countryside. And the challenges with that are that you've got to be able to obviously cope with the weather and the seasons, any pests and other diseases that might have an effect. So they've taken that and built it inside essentially a factory on the edge of large cities. So they've built these farms in a vertical fashion where they have trays of plants growing in a hydroponic situation that are built up into layers inside of these warehouses where they can control the environment. And what that's allowed them to do is to be able to build sensors throughout the plants. They have cameras watching the plants grow, and they can use those cameras to tell when the plants are healthy and how fast they're growing. They also have sensors into the hydroponic solution that's driving that, so they can see the nutrition and the way the plants are responding to that pretty much in real time. So they've built these models that actually allow them for some plants to be able to accelerate their growing cycle. So rather than having, one or two sort of crops per season, they're now able to bring that down to sort of a dozen crops a year. So they can control the light and bring the light and the day and night elements to optimize the speed at which they can grow those crops. They can also make sure that they've got the maximum amount of nutrients in it for us as humans to consume. And because they're doing this right on the edge of cities and disused warehouses, the time to be able to get these crops to the markets and into the hands of the people that are consuming them is dramatically reduced. And so they've built these kind of feedback loops of data and insight, so they can see how much of their produce is being consumed or purchased through a supermarket today. So they know exactly how much to harvest and to supply to those supermarkets tomorrow. So there's very little wastage, there's very little kind of overflow in terms of that. So that's allowed them to dramatically improve the yields and the type of service that they're offering to those kind of marketplaces. And in fact, AeroFarms actually refer to themselves as a data company, not as a farm and produce company. So they believe that the data that they're collecting and using to create these business models is far more valuable than the produce that they're collecting and producing as part of it.